This video is all about finding the z-value given such area. Here are the steps in finding the z-value. We have to use the z-table to find the nearest value closer to the given area. And for uniformity, we're going to use the greater value if that is the closest area to the given area in the problem. Okay, let's begin. So remember, use z sub 1 to denote the z-value before the given area and z sub 2 to denote the z-value after the given area. If the given area has a corresponding z-value on the z-table, then take it. On the other hand, use z sub f to denote the final z-value after finding the average of the two previous z-values. Okay, to illustrate here, we're going to have an example. So this is now the formula to use to find the final z-value. So z sub f is equal to z sub 1 plus z sub 2 divided by 2. And if the given area is more than 0.5, 0.50, 0.500, or 0.5000, then we must split the area. For example, we have here 0.75. To split this area, we must do the following. 0.75 or 0.7500 is equal to 0.5000 plus 0.2500. So this is the way we're going to split the given area. Okay? Next. So let's try some examples. Okay, we have here 5, but we're going to do the 3 examples only. So we have here the first example. Between the mean and z is 0.38. In this problem, the given is only the area and the missing is the z-score. For us to find what is the value of the z-score, we must first express the given area into 5 decimal digit form. So that is 0.3800. And then we're going to consult on the z-table for the nearest areas before and after this given area 0.3800. So upon consulting the z-table, the nearest area before is 0.3790, that its corresponding z-value is 1.17. And the nearest area after the given area we have here is 0.3810, then its corresponding z-value is 1.18. As you can see, the two nearest areas has only 0.0010 before and after the given area. That is the interval, 0.0010. So now, we are going to use the formula, which is z sub f is equal to z sub 1 plus z sub 2 divided by 2. Then, we're going to substitute the given. So for z sub 1, we have 1.17. For z sub 2, we have 1.18 and divided by 2. So add the 2 on the numerator. We have 2.35 divided by 2. That is 1.175. Then round it off to the nearest hundredths. That is equal to positive negative 1.18. So therefore, we must take the second uh, z value, that is the area after the given area. That is 1.18. This is now the z value. So we're going to take the second z value after the given area if and only if their interval is equal. For example, this one, the first area is only 0.0010 before, and the area after is also 0.0010 after the given area. Now, the next step to do is to draw a normal curve and locate the z value. So we have to take the positive first, 1.18. It must be here approximately, and draw a vertical line. Then, the shaded part is from this vertical line going to the center or to the zero or the mean. So this is now the shaded part. So since it is positive negative, we can take this problem as z is positive or in negative. Okay, so for negative, this would be the image of the graph. So this is now the shading. So this is now the shaded part or portion of the problem. Between the mean and z is 0.38. Then, what would be our conclusion? Thus, between the mean and z equals positive negative 1.18 is approximately equal to an area of 0.38 or 38%. So we are now done with this problem. Okay, next. Number 2. To the left of z is 0.90. So the given here is only the area to the left of z, which is 0.90. So first thing to do is we are going to express this into a 5 decimal digit form. Okay, that is 0.9000, and then we must split this area, since this area is greater than 0.50. So that is the split must be 0.5,000 plus 0.4,000. Then, given this data, we're now going to shade the part for 0.5,000, since the 0.5,000 represents the half of the curve. Since the problem is to the left of z is 0.90, then the shaded part or the half must be on the left. So this is now the figure. So we already shaded the half on the left of the curve, and then we must have to look for the z value, okay, near the area 0.4,000. Okay, so the remaining area is 0.4,000. Then we must look for the nearest areas before and after this given area. And upon consulting the z table, the nearest area before is 0.3997. Its corresponding z value is 1.28. And the nearest area after 0.4,000 is 0.4015, and its corresponding z value is 1.29. In this case, as you can notice, the first area or the area before has only 0.003 before the remaining area, while the second or the area after is 0.0015 after the remaining area. That is the interval. So we must take the first area, okay? Since that is the closest area to our remaining area, which is 0.4000, then we will take its z value, which is 1.28. That is positive. Okay, then we're going to locate that z value on the curve. So that is now the location approximately. Then we are going to draw a vertical line. Then we shade this part of the curve. So this is now the shaded part. So this is now the area for 0.90. So our conclusion would be, thus, the left of z equals 1.28 is approximately equal to an area of 0.90 or 90%. So we are now done solving the problem here in number 2. Okay, please take a look and have some observation before we proceed. Okay, next. Okay, third example. Between positive negative z is 0.27. Okay, the area given is 0.27, and we have here z is expressed in positive and negative. Therefore, the z value is positive and negative. So the first thing to do is to express this area into 5 digits form, and that is 0.2700. Then we must split them into 2 since we have here positive negative z. So that is equal to 0.1350 plus 0.1350. So this is now the division, okay, the partition of this area. Okay, then we're going to look for the nearest area before and after 0.1350 on the z table. Upon consultation, the nearest area before is 0.1331 and its corresponding z value is 0.34. Then, for the nearest area after, that is 0.1368, its corresponding z value is 0.35. Now, in this case, since the area after the given area is the closest, then we will take its z value. Why? Because the nearest area before it is 0.0019 before the given area, and this area after is only 0.0018 after the given area. Okay, so you must take the z value, which is 0.35. Then, let's draw a normal curve and locate z equals 0.35, positive and negative 0.35. So, we have here negative 0.35 and positive 35. Then, we draw vertical lines. Then, we will going to shade this part. So, that is now the shaded region. Then, our conclusion would be, thus, between z equals positive negative 0.35 is approximately equal to an area of 0.27 or 27%. Okay, that's all. And I hope you follow and you understand all the steps we did in the 3 examples that we have. Okay, so thank you for your time. If you have any questions, you may have a message on my Facebook account. So thank you for listening.